I don't like this place, nor should you. I don't like this home lab, nor should you. I don't like wasting time, nor should you. I don't like wasting money, nor should you. Safety never takes a break, nor should you. A few grams of gold is never worth a lifelong injury or worse. Thought this was just another boring safety video? Think again. The temperament of a good refiner. What kind of personality or mindset is required to refine precious metals safely and responsibly? A successful refiner is marked by patience and a teachable spirit. They take the time to read, listen, and ask questions. Every step is approached with deliberation and precision, not haste. They minimize mistakes by learning from others through study, reflection, and respectful inquiry. On the other hand, those who approach refining carelessly as a hobby without the necessary discipline or mindset may want to consider a different hobby. Pickleball, perhaps. What is your purpose? Define your purpose with clarity. Keep your scope focused. Before chasing complexity, master the fundamentals, especially the art and science of basic refining. Focus on doing one thing well, develop your own style, perfect your process, and only then evolve to the next logical step. What is my purpose? My purpose right now is simple: to refine only gold from electronic scrap using small, discrete, efficient, and time-tested methods. After strictly adhering to the principles mentioned in this video, I am very pleased to share with you the results of my work after 1.5 years of studying and reading. This is the lane I'm staying in for now. I'll move forward only after I've researched and fully understand the next phase thoroughly. It's interesting and somewhat counterintuitive that gold, one of the most valuable metals in the world, might actually be the easiest metal to refine, at least in my experience. At this point in the video series, no chemicals have been opened yet, and for now, that's exactly how it should stay. Required reading. Please read this book. It is the absolute first step for any beginner in this field. It is called Refining Precious Metal Wastes by C.M. Hoke. It is available everywhere and is required to read. You can order the acid-resistant version on Amazon. Personal Protective Equipment, PPE. PPE is the equipment worn to minimize exposure to hazards that may cause serious injuries and illnesses. PPE isn't a suggestion, it's a requirement. Skip it once and you might not get a second chance. Respiratory protection. All chemical experiments and processes must be conducted only in a properly functioning fume hood or outdoors to ensure safe ventilation. Never perform any chemical process in a house or a garage. Respirators are complex and require thorough research before use. No respirator can adequately protect your lungs from aqua regia fumes, which are all highly toxic. Wearing a respirator while working with aqua regia fumes is strongly discouraged, as it can create a dangerous false sense of security. As a side note, these N95 masks are useless and offer no protection against chemical gases. Use them while sanding your wooden table in your backyard in your spare time. Eyes, nose, and throat protection. I always wear full safety glasses, often paired with a full face shield, depending on what I'm doing. Splashes happen, beakers break, flasks tip over. If you wear contact lenses, be extra cautious. They can trap harmful chemicals against your eyes. I personally wear contact lenses and have never had an issue. Hands and skin protection. I always wear long sleeves, long pants, sneakers, and a lab coat to protect my skin from chemical exposure. For hand protection, I use heavy-duty black disposable nitrile gloves, 6 mil thick, fully textured, powder-free, and latex-free. I like the black because the gold flakes will show up on the black color. When working with heavier acids like aqua regia, I also wear reusable heavy-duty, thick nitrile, chemical-resistant gloves with microfoam textured palms, providing protection against acids, alkali, and oils. I'll put those on over the 6 mil gloves. The lab environment. I have several layers of safety built in to refine safely and responsibly. I work no less than 150 feet away from my house. I also have several items of glassware and pans below my beaker and several layers of protection on the ground under my lab table. Nearby, I keep emergency supplies within easy reach. I will keep a garden hose, 2 spray bottles filled with water, and a large box of baking soda, which is sodium bicarbonate, for neutralizing acid spills. Chemical do's and don'ts. Never mix chemicals unless you fully understand the reaction that will occur. Unpredictable combinations can be dangerous or deadly. When making aqua regia, we use the incremental nitric addition method, which means slowly adding nitric acid to the hydrochloric acid. The key here is slow, small additions. Always add the nitric acid to the hydrochloric acid, never the other way around. It is at this point that the aqua regia fumes begin to form and escape the beaker. They are dark brown and orange and are highly toxic. Denoxing and precipitation safety. After the gold and base metals are dissolved in the aqua regia, it is important to denox the solution. Denoxing means removing the extra nitric acid in the solution. Extra nitric acid will cause all kinds of problems when you go to precipitate the gold. Many refiners use urea. However, I was taught to use sulfamic acid. Sulfamic acid. This needs to be added to warm aqua regia slowly, as it may cause a violent foaming of the aqua regia. And finally, to precipitate the gold out of solution back to a metallic state, I use the selective precipitant sodium metabisulfite. You can buy it in a hardware store under the name of Stump Out by Bonide. When adding this precipitant to the aqua regia, it must be added slowly because it may cause a foam up and a reaction, and you may lose a lot of your gold. Additionally, it releases an awful sulfur smell that you want to be ready for and not get into your respiratory system. Smart glassware practices. Please use high quality beakers in your processes that are made for chemistry and lab use. Additionally, please don't thermally shock your beakers. That means don't put a cold beaker on a hot plate. It will fracture and your liquid will be everywhere. And finally, I always use beakers larger than necessary to provide extra space in case of a boil over or runaway reaction. That extra volume can prevent spills and contain unexpected foaming or gas release. I also partially cover the beakers with a watch glass. And now it's time to list my 7 top beginner mistakes. Fortunately, none of them were too serious. Number 1, putting fully populated circuit boards into acid peroxide. What a mess. Number 2, broke 2 beakers, thermally shocked 1, and knocked over a flask. Number 3, I lost gold while decanting. Number 4, I had a beautiful runaway reaction, which I'm not proud of, when I added nitric too fast. Number 5, I stood too close to an SMB precipitation and got a very small whiff of that wonderful sulfur gas. Number 6, I used black zip ties near the acid peroxide bucket to secure a hose. They dissolved and turned into a blob. Number 7, I used my wife's clear Pyrex casserole dish on top of my hot plate. Complete and utter thermal fracture. There were thousands of pieces everywhere. She is still looking for that casserole dish. Please be safe. AU 79.